Hey, we're talking about the distance formula in this video here. We talked about finding the distance between 2 points on the real number line, but now we have projected this and added a different dimension, so now we have two dimensions to work with and not just one. So let me construct the Cartesian plane. Alright, we want to label two arbitrary points here. Let's say, for example, we're going to take this point here, and we'll say this is 1, 1. And let's say, I don't know, we'll make this -3, and this over here about -3. Now, we want to find the distance between these 2 points. And let me Okay, so there's our green line right there, and we want to find the distance between these 2 points right here. And what we're going to do here is use what's called the distance formula. If you can think of this as for example, a right triangle, if you remember how to find the distance of the hypotenuse of the triangle, remember that it was the Pythagorean theorem, x squared plus y squared is equal to r squared. Well, that's kind of where the distance formula pretty much comes from. But our ordered pairs here, which we'll call 1, 1, and then this ordered pair here is going to be -3, -3. So if we know this distance, right, we would square it, and then if we knew this distance, we would square it, and then add them both together, and then square root it, and that would give us this distance here. Remember the Pythagorean theorem. X squared plus y squared, and then if you square rooted all of it, you would get r, or in this case we'll say d for the distance of the green line right here. Well, in order to find this distance up here, we're going to take the difference between the two x values. So that gives us the distance, right? Remember the distance between 1 and -3. Now, going back to finding the distance on the x-axis, okay, we would take our 1 here, and so remember it was b minus a, and -3 is a and 1 is b. We would say 1 minus a -3, so we would say 1 minus a -3. Now remember, that's the difference, or the distance. And what are we doing here? We're squaring it. So we want to square it. Plus, right, coming from our Pythagorean theorem here, plus y squared. And so we want to figure out what y is. Well, y is going to be this distance from here to here. Now, to find this distance here, we'd end up taking -3, or this -3 here, and we want to go up, right? And we're at 1 here, okay? So let's look at this again real quick. I'm taking 1 and I'm subtracting it from the -3 here. So I must do this in the exact same order. I'm going to be going this next one right here and subtracting and going minus this y value here. So 1 minus a minus 3, right? And we're going to square that because that's what it says to do in the Pythagorean theorem. And then we're going to square root all of this. And this is going to end up being the distance of our green line right here. Distance of the green line. So let's just work out the math. And so we end up having 1 minus a minus 3. This is going to be 1 plus 3, which is 4. And 4 squared is 16. Plus, and of course we get the same thing here, 16. And that's the square root of, and that's going to be 16 plus 16 is 32, and 32 is not a perfect square, so we're not going to get a natural number here. We're going to get something else. Well, after plugging this into the calculator there, we get, I don't know, it's approximately, these little squiggly lines mean approximately here, 5.65, right, and then it's got a bunch of stuff after that. So we got this irrational number here, but it's approximately 5.65, so units. Distance formula, better get it down. You're going to be using a lot of it. If you've had college algebra or algebra, you should have already memorized this by now, but this is just a brush up. That's all this section is just to kind of refresh your memory. So pretty simple, right? The general formula, I guess I need to state the general formula here. Okay, if I've got a point here in the Cartesian plane, and we'll call this x1, and we'll call this y sub 1, and we got some other point over here, and we usually call this x of 2 and y of 2. And we want to find the distance between these 2 points here. Trying to find the distance, so we use the distance formula, and remember it goes like this. It's the distance, and this is going to be all square rooted. So what we're going to do is we're going to take, for example, x of 1 minus x of 2, and by the way, it doesn't matter. You could say x of 2 minus x of 1 as long as you say y of 2 minus y of 1. So you got to have this same follow-up type order. Usually they'll say x of 2 minus x of 1, and of course we're going to square that, plus y of 2 minus y of 1, square that, and square root all of that, and that's going to be the distance between these 2 points. Now I want to say this again one more time. I could have x of 1 here minus x of 2, but if I do that order, then I must have y of 1 minus y of 2. You're going to get the same answer. Alright.